This is our GE microwave, and it's not heating up. And we already took it. This is over the range microwave. We already took it down. The model is let's see, JVM617-5SF1SS, and it's not heating up. And we'll check like what is problem with this one. To open it, to get to the parts, we got some screws. On top we have 1, 2, 3, 4, 5. 5 screws we have to open it on the top, and then on each side we have 2 screws, and on this side too, 2 screws. And on the back we got 1, 2, 3, 4, and 5 screws on the back. We need to open it, and then we can get access to all those parts like transformer, magnetron, capacitor, and diode, and we're gonna check those and see like what is wrong with it. And then we have 5 screws on the bottom. 1, 2, 3, 4, 5, and actually 6 screws. We have to open those. Light, and we need to disconnect those. Okay. For the surface light, and then this is for the okay. So just came out. This is the GE microwave, over the range microwave. The problem is everything is working fine, but it's not heating up anything. So I mean, there are some parts you have to check it. This is the magnetron main part, which heats up the food inside the microwave. This is the step-up transformer, and then this one we have a capacitor. This is the most dangerous part. Even if you unplug it, make sure you have to discharge that capacitor with the needle nose plier, and make sure you don't touch the metal part when you discharge it like this. It's gonna give the spark, because it does have like 2000 volt to 5000 volt. This very high volt. And then this is like diode. One of these things might be not working, but we'll check like one by one, and then we'll see like how I'll show you like how to check each of the part. We will check the capacitor and the diode. First, make sure like you unplug the cable, and then discharge with the needle nose plier. And after that, you have to take those wires out, and then there is a screw right here. You have to unscrew it, and then take those capacitor and the diode. This is the diode. We need to take those out too. This is the most dangerous part. It can get shock if you don't know what to do, or you know how to do it. So let somebody professional do it. Okay, now you would need to take this screw, open this screw. And then to take the diode out. To check the diode, you have to have the multimeter and the diode, and then turn it on, and then make sure you put it on the highest on the ohm meter, 2000K or whatever you have in your meter. It should give you some reading on this right here, and then it goes to infinity like 1, and then when you switch it, it should do the same thing. So it means it's holding the charge and discharging. So the capacitor is good, and let's check the diode. Okay, to check the diode, you have to set the multimeter to DC volt, because the diode, it does allow the current flow only in one direction. So let's go put this one like negative on this terminal, and then you have to have the 9-volt battery, and then check it like this. It's not flowing, it's showing the 0. Then if you go opposite direction, it should give you some voltage. You go other direction, it's not allowing the current to flow this direction. So it means the diode is good too. Okay, now we're going to check the transformer. This is like a step-up transformer. It takes 120 volt input and give you almost 2000 to 5000 output. So this is the primary, and this one is the secondary, and you will check both windings. Let's check the primary winding first. We have to disconnect this one. And I showed your multimeter, you put it on ohms. The lowest range is like 200, and it should give you the continuity between those two primary windings. Maybe like 1 or 1 point something, but very low ohm reading. So this primary looks like okay. Primary does have that thicker wire, and the thinner wire is right here in the secondary. And then let's check the secondary. Secondary, 2 wires, those 2 red wires going to the magnetron. And let's check this one out. And these 2 wires give us continuity too. Let's check. And then on the ohm meter or multimeter, yeah, it's giving continuity. Okay, and then there is one more white wire coming out of the secondary winding, and it should give you like almost more than 120 some reading, 120 ohms reading. Let's check with the ground. See, 125. So the transformer looks like okay. All primary and secondary, they're not open circuit, they just, they should be working fine. Now last thing we got left is magnetron, and we will check it. We will check the magnetron right now. How to check a bad thermostat in a microwave? Doesn't matter, like it's over the range microwave or on the countertop microwave. The thermostat, what the function of the thermostat, like if you set up any setting, if it is not good, it won't let it will stop earlier than that required temperature, or it will burn the food. So this is, if you're having problem with the like it's heating up too much or it's not heating up. So this part is might be one of the problem beside the magnetron. Magnetron is most of the time is bad. So let's check the thermostat, and for that you have to have the multimeter, set it on lowest ohm meter range, ohm range. It's like 200, and then you have to have the continuity between those two terminals of thermostat. Okay, looks like we do have continuity, and should not have continuity with the body of the magnetron. So it does not have continuity with the magnetron, with the body of the magnetron. So looks like this is a good thermostat. Okay. Now the last thing in this microwave I got left is magnetron, and we're gonna check the magnetron if it is working fine or no. To check that magnetron, make sure you unplug the cable, unplug power source, and then this is capacitor, and make sure you, after you unplug it, you discharge it, because this one has like 2000 volt to 5000 volt. This may be dangerous, and when you discharging it, make sure don't touch any metal part of the long nose plier or needle nose plier. Okay, so to check the magnetron, we need to disconnect this cable from here and check the continuity between those two terminals of the magnetron, and make sure to put that multimeter setting to lowest range of the ohms, like it's 200 ohms. It should give you some reading continuity. Let's see. Okay, looks like, yeah, we have very low reading, 1.5. So this looks like okay. Okay, if we have new magnetron, that one will do the same thing too. But there is one more check, and this is very important. We need to check those terminals with the ground. If the magnetron terminals give continuity with the ground, then it means the magnetron is bad. And the new magnetron will never give you any continuity with the ground. So let's turn that ohm meter setting to the highest reading, which is 200K, and with any one of the terminal, and then touch to the like screw. Okay, looks like this is short with the ground. Same thing, I think. Yep. So looks like we have to replace the magnetron. Magnetron is bad, because if it is giving continuity between the ground and the terminal, it means it's short to the ground, and it's not going to work. Okay, to replace the magnetron is not too hard. Just need to take those two screws out, and then it is going to come out, and then unplug these, and then the magnetron is going to come out. You can just put back the new one, and it should be working fine. How do you check the bad magnetron or good magnetron? This one, we have the bad magnetron from a GE over the range microwave, and this one I just bought the new one. And how are we gonna check it? There are two checks. Actually the microwave was not heating up at all. So how do we check? I took it out, this one, we ordered this one. Well, let me show you like how to check. So between those two terminals, we should have the continuity, and you can see right here on the meter. Keep the meter on like lowest range, like 200 ohms, and it's showing the continuity. And this is the new one, the one we bought it. So it's same thing. So what is the difference? Okay, let's check this one with the body, this terminal with the body. Put that ohm meter reading to maximum ohms, like 2000K. So So just check these terminal with the body. There is no continuity. There is no continuity with this one either. This is the bad one. Okay, looks like this one does have continuity. Both terminals have continuity. So this bad magnetron is shorted to the ground, and that's why it wasn't working. This is the new one. So that's how you check it. This is the microwave. We just changed the magnetron on it, and let's see if it does work. It wasn't heating. So let's try 3 minutes. Three minutes almost done. Let's see if it does work. Okay, you can see the steam coming out from the water. This was the only reason to do the 3 minutes instead of 1 minute or 30 seconds. So you can see in the video that it's already working. Okay, looks like the magnetron and everything is working fine.